Welcome, everyone. This is the last talk of today. We know that this is difficult because we are the very last of the obstacles on the way to after party, so we will try to be sharp and stay under 40 minutes. That should be max. My name is Maciek. This is Paul. We work for VPTech, and we are going to speak about the topic of splitting the monolith into modules. That's going to be literally the journey that we took over the past several months in our company, and we are going to speak about some good results that we observed, some good impact this project had on our code base and on our team. To start with, we need to give you a little bit of the background of our company. So we work for VPTech, which is the community of Vente-privee group. We are the tech community of Vente-privee group, and Vente-privee group is something wider. In Vente-privee group, we have multiple companies. Just to name a few, it's Vente-privee for the French region, it's Privalia for the Spain, or Złote Wybrzeże for Poland. We deliver the e-commerce experience for people all over the Europe. Inside VPTech, we are more than 800 people working on different areas. Just to name a few, those are things like client applications, so web, mobile. Those are people who work for the IT, for warehouses, because we own multiple warehouses across Europe. Those are people working on back office tools that are used for preparing the media assets for our e-commerce business to sell things. We have multiple offices. Just to name a few, it's Warsaw, it's Paris, it's Barcelona, Tel Aviv, which is not the island. It just didn't fit the slide. Sorry for that. And with Paul, we work for Vente-privee, and we work on the application. We work on the Vente-privee iOS application, which is currently number 4 in French App Store under the shopping category. To give some numbers behind this application, we have up to 1 million active daily users buying things on our platform directly on iOS. We do release the new version of application every 2 weeks, so we have this regular release train. And we work in our application. Our business is based on the flash sales model, which means that every day at 7 a.m. we have a peak of users who jump onto our application, onto our platform, to see what are the new sales that we list for them. And to go further, Paul will give you some bits of more insights about the team and how do we organize.
Yes, so how do we organize 800 people across Europe, basically in our company? So we have product teams around the company. So basically, in our department product team, I'm going to give you 2 examples. One is like the marketplace team, which takes care of the buying experience for the users on the app, like browsing the catalog, getting details for products in the product sheets, and after like displaying some details on the products. Then we have like the other team, could be like the order pipe, which take care of the buying experience for the users, like having like a summary of their order, like they choose the delivery system, and then at last they pay, of course. And each team is composed of multidisciplinary people. Like we have PO, Dev, UX, and like when I say Dev, it's like Android, iOS, backend guys, and web developer too. So how do people with the same expertise, like iOS, work when we are not in the same team nor in the same continent sometimes? So it's very simple. We work in chapters. So for us, the iOS chapter is composed of 10 developers. So 7 of us are in the product teams, like me. And 3, like Maciej, are in the core team. And the core team is pretty different from the product team because an iOS developer on the product team is like more in charge of the front-facing feature for the customer, whereas Maciej and the 2 other guys on the core team are more responsible for the transversal parts of the architecture in the iOS application, the core components too that we use, as well as responsible for our CI and infrastructure.
Going more serious about these 10 iOS developers. So how can 10 iOS developers work effectively on one single project? This is the question. This was the challenge that we asked ourselves several months ago, and we came up with the conclusion that our code base was not in a good shape. It was not in a perfect shape because of several reasons. To name a few, it was really hard to understand because there was no single architecture standing behind it. We were using something like MVC, but we were not good at it. It was not the perfect usage of MVC. It was taking long to compile. Because of that, the unit test execution, so the development cycle, was very slow. Because of that, we had very little test coverage, and because of that, it was difficult to refactor, because everyone was afraid of changing things and breaking stuff. Last but not least, there was very little reusability of the things in our code base. The solution for this, like the root cause of the problem, was pretty obvious for us. We were 10 people working on a single Xcode project, on a single application, so this couldn't be okay. Because, for instance, the Git configs that we are receiving very frequently on the single Xcode project. To name some other pain points, Paul will continue.
Yes, so the first one that we identify was like the exploding complexity of the code base. And because of like, what were like the most important factors of that exploding complexity, though the first one was those fast static objects, like this one, the web services responsible for all the web services calls inside the application. Furthermore, like it was a static class function, so not really good. And like those huge fat static objects were used inside our view controllers, of course, directly. So it turned out like we have like huge, massive view controllers, like kind of the like big stuff that were mostly like doing. They were responsible for fetching the data from the web services, translating it into some business logic data, then handling also like the view logic too inside them. So we had like those massive view controllers that weren't really testable. So we had like a low test coverage, of course. And when a dev wants to refactor something, like he doesn't want to be the guy that will break everything because of the regression risk that it will and then like bring. So it was the first pain point and the first like a vicious circle that we identified. So like complex code brings more complex code because devs doesn't want to refactor. So each time they add an if in the code, it becomes a more and more complex code. So the second point was the little abstraction that we had in our code base. So to give you a concrete example, the first one was core data. So we used core data the wrong way because I think it can be pretty useful. So basically, what happened was we were fetching those responses for the web services. Then from that, we were creating core data objects that follow basically the same schema. And then after, of course, we were sending those objects in all of the layers of our application, so up until the view controllers. So unfortunately, with core data, we have like a lot of Objective-C types, like NS numbers that are not really easy to work with. Then a lot of optionals too, because it was directly mapped from the web server responses. So once again, no test, and once again, kind of a vicious circle where bad abstraction tends to force us like to do dirty hacks to steal right features, and then it leads to bad abstraction again.
The next point was the next pain point was about the mess. As a human beings, we love when things match. We love, as a programmers, we love patterns. So we love to reuse code. In our code base, it was very difficult to reuse the code because there was some little mess around. So we were either not reusing the code because it was hard to spot the things that could be used once again in some different place, or what's worse, we were reusing things in the wrong way by breaking some of the solid principles. This led to another vicious cycle of the mess and people duplicating or not reusing the things, which led into more mess, which was dangerous. Last but not least is the waiting time. So we all programmers, in our job, we compile a lot and we wait a lot. For us, the problem was that several months ago, it took over 15 minutes on our CI machine to build our solution from scratch, just from the clean build. We, of course, applied some of the compiler optimizations. We played with some different compiler flags, with some techniques. So we reduced it like significantly, but it was still not enough to jump into this fast and robust development cycle of running tests, iterating on our UI, and doing everything in a nice and satisfying way. This led to frustration. And the general rule of life is that if you do nothing to the frustration, it will not disappear. So stepping back and thinking about this, like what we did, the exercise that we did several months ago, we stepped back and we looked at this in a predictive way. So we were trying to predict what's going to happen in the future, and this is what we came up with. So with the evolution of our code base, the development friction was increasing. It was increasing, which was dangerous, because if we were about predicting the team happiness on that chart, it was obvious for us that it's gonna go down. The team happiness, so the happiness of developers working in your team, is a very crucial factor, because if you fail at that level, you will have problem in 3 areas. First of all, unhappy developer cannot bring a nice contribution to your product. So your product is more likely to not become better because you have unhappy developers. First of all, unhappy developers is danger for himself, because he doesn't evolve. He doesn't develop new skills, so he may not make a progress in his life. If the developer is smart enough, he will quit the job. And this is the third area. So you're affecting the company. If the developer quits the job, you need to hire a new one, you need to pay money, you need to onboard him, you need to waste time to get him onto the same level that the guy who just left. So because of that, because of looking a little bit further in the future, we need to challenge the status quo.
Yes. So obviously the answer was like breaking the monolith. So, but we were like really pragmatic about that. That monolith were running for more than 2 years, and it was making a lot of money. So, like we couldn't say we will refactor it overnight because we could introduce more bugs and it won't be cool. So, what we decided in the place that every new feature we will start will take place inside a framework or a library, which is more like a single responsibility piece of code. And from that, the development benefits come really like from taking all the new features to the frameworks. And of course, at the, along the way, it will reduce the size of the monolith. So how does our code base look like today? Oops. So we still have that huge monolith with all the persistence layer, all the massive view controllers, and all the old networking way of doing. But now, when we wanted to start a new feature, we created a product module for each product teams and for each developer in that team. So firstly, that brings a strong ownership for the developer, for the code, and for his team. And what's inside each product? So basically, of course, all what is needed to do the feature. So from the view controllers, the view models, the storyboards, the assets, and the business logic. But in the meantime, the core team was really working hard too. And they were doing some what we call the libraries here. So it's much more like there is no features in those libraries, but more like single responsibility piece of code. And as in the first example, the VP translator, which brings the translation and the the localization logic from that library. Or another one could be the VP network, which of course brings the HTTP client in a more nicely way. And looking at a wider picture, we could have established some strong rules that are really beneficial for us. So the first one is like the main target, the monolith, depend on all the products modules. Then the product module depends as well with the monolith when needed from all the libraries that the core team does. And like neither product module can't reference themselves, so it makes things really separated and really we don't share so much logic between, we share no logic between them. And as I said, the products are owned by the developer and the product teams, and the libraries are owned by the core team. But of course, there is one exception that Maciej will talk about.
Yes, so the VP Commons library. As Paul said, we don't share the code directly between the product modules. For that, we created the VP Commons library. So when working on that design, when designing that map, when decoupling our solution on our monolith into that modules, we were sure about some of the core responsibilities, like VP translator, network, or monitoring. But at the same time, we knew exactly that we will need some place to share some little pieces of logic between the product modules. I mean the logic like currency formatting or date formatting. This is something that was used in all the products, so we needed some place to put it on. That's why we created the VP Commons library, because at the same time, we wanted to stay small and to not over-engineer. So we didn't want to plan further and to decouple the problem more, because that costs the time. So we created one single generic bug for everything. The rule for VP Commons is that it's important by all the product modules, including the old monolith. If we look inside VP Commons, there is a huge diversity of things that are inside it, including some assets, including some UI components, including some shared utilities like authentication logic or some network utilities, even some shared pieces of business logic. So this is literally a bug for everything, and we try to make the decision-making process as seamless as possible. So every developer from a product team is free to put some stuff into that library. We know exactly that this library is going to grow and grow, but until it explodes, we want to look once again into what's inside, then think about splitting it, dividing, and conquering the problem.
So now let's look at what's inside a product module. So for the first example, it's marketplace, and as I told you earlier, the marketplace is responsible for like the browsing experience of the products on the app. So those different screens with the catalogs and the product sheet. And now let's look at how it's composed. So we have like the coordinator, which is responsible for handling all the flows of the marketplace screens. So the screens for us are those screens, which are composed of the view model and the view controller together. And of course, there's like the API with like the API calls and API responses, as well as the business logic and business model of the marketplace. So self-contained inside the module. But now, how do we use our module inside our application? So it's like really, really simple. And as Paul told earlier, so we just have to import the module inside the Vente-privee app and use the coordinator that is public. So we will instantiate it and just start it. And after, marketplace behaves, and it's not a problem anymore from the monolith. So now, as we said earlier too, that the building process was really long, and it could make things more difficult, like even with that module, to continue to develop new features, and we wanted to go faster on that way. So what we decided to do, like we decided to create the marketplace demo app. So it's basically just an empty shell, importing just the marketplace. And now, while developing, we can iterate faster on the flow of the marketplace with the coordinator or on specific screens.
If we have a look into another product on our map, so user engagement. This is the product that is responsible for the initial experience of the user in our application. This is not only the sign up or sign in flow, this is something more, like things like onboarding or the GDPR legal stuff. So once we look inside, it looks a little bit different than the marketplace module that Paul just showed you. It's because there is no coordinator inside. Inside user engagement module, there are only screens. Screens are responsible for flows from that product. The way we represent screens is view model and view controller, because we use kind of MVVM architecture. So where is the coordinator for user engagement? The answer is inside the monolith. So inside the good old monolith, we have the user engagement coordinator together with some networking logic for that, and together with some business models responsible for delivering some object from that domain. The way we integrate monoliths with the user engagement framework is by simply creating different instances of that screens. And the coordinator that is laid inside monolith takes the care of navigating between them. So what is the benefit of keeping only the screens inside the user engagement framework, inside the separate framework? Similarly to what we did with Marketplace, we created user engagement demo application, which is different from our monolith, our long compiling monolith. We have user engagement demo, which is pretty much empty shell for only hosting the user engagement framework, which means that we can compile and iterate on this very quickly. Inside this demo application, we have very technical screen that lists few buttons, and each of that buttons can navigate us directly to one of the screens from user engagement project and display it with some stubs or pre-configured state. So it means that we can very quickly iterate on things like successful login page or the failed password reset experience. So, and with this, with the fast iteration cycle, we invite developers to cover that logic more and more with tests, because it no longer takes minutes to run it, it takes even seconds. If we step back, why did we decide to employ different strategy for user engagement and different one for marketplace? So, once again, quick recap. We have user engagement with the screens inside, we have marketplace with screens and coordinator inside. The coordinator for user engagement is inside the old long compiling monolith. We did this because the difference is that user engagement was created by moving existing view controllers, existing screen logics from the monolith to separate framework. We created the framework and we started moving screens one by one to that quickly compiling module. And if you move code, when you move code from the old monolith to a new module, you want to do this in small pieces. It's because the small piece of code is more likely to have small dependency on the rest of the monolith than a huge piece of code, like for instance, coordinator. We decided to move only the screens, and this gives us already like the quick compiling experience, so we can iterate on this very quickly. The coordinator is laid in monolith, and we are OK with that. In case of marketplace, however, the situation was slightly different. Marketplace was a module created from scratch, so there was zero dependency on the old code. With that, we were able to create coordinator, create new screens directly in that module, and start iterating on that, then integrate it in the VP application, in the main target. When we add the demo applications to that, we can come up with these two differences. So the first approach is efficient for legacy code, when you need to move something to a module. The marketplace approach with coordinator inside is efficient for new features because zero dependency at the beginning. This one gives you quick iteration on single screens, and this one lets you iterate on the entire flow. Speaking on dependencies, there are very technical things behind that, and Paul will continue on that.
Yes, so we wanted to start developing new features for the user engagement, so I'm going to keep that example. And the first thing to do is like to identify where like the screen you want to move inside your module resides in your code. So of course, in the data manager, the worst thing in the world, the two words that developers shouldn't put together. Once, like when we are here, like we identify the code. Now it's pretty easy to continue on to the flow to moving that view controller to the user engagement. We just abstract the part that is used inside the data manager behind the protocol. And once this is done, we can simply move all that part inside the user engagement module. So now what happened and what we can see is that thanks to dependency inversion and like more generally like the anti-corruption pattern layer, we are hiding all the mess from the monolith from the user engagement framework. So now, like as we said now, we have like a much more faster compile module, and we can even start to introduce a new architecture and design pattern, like view model and repositories, and even add tests to be sure that our code is now running and we don't make regression in the future. So what is also cool with that approach is that now we can simply include the new libraries developed by the core team, like for instance the VP network, and now it's really clear that we don't have any more dependencies on the old monolith code base. So we can simply remove the code that is not used anymore. And on the long run, it is really efficient because at the end, we can remove all the dependencies like from the data manager or even core data that we plan to remove.
Okay, writing code in the modular world is only half of the story. When we were about to enter the journey of modularization and of this project, we needed to consider also some other things, like how to host code in a kit, how to link dependencies in Xcode, or how to make the entire team work on different modules in one single GitLab instance. So I'm gonna talk about all these things. For the modules, every module in our modular architecture is single separate Xcode project. In that project, we have 3 or 2 targets. For instance, for user engagement project, we have the user engagement framework, which is purely the logic behind the user engagement. So all the view controllers or the view models, all the visual logic, etc. We have the tests where we can iterate quickly. We have the demo application where we can iterate on UI part. Slightly different situation is for the VP network, which has no UI because this is only the networking library for us. So we store all the code in that framework and we iterate on unit tests in that one, which is pretty cool because thanks to the separate project, we can compile it very quickly. So we were able to deliver the full TDD approach to that, and we reached over 90% of coverage in that single module. Speaking about dependencies, so the legal way that Apple suggests to handle dependencies is by leveraging Xcode workspaces. So this is exactly what we did. For every module, we have a separate workspace where we put in all the projects that the module depends on. On that case, in that example, the VP Commons library depends on VP Network Translator and the response handler. The same applies for third-party dependencies because we are using Cartridge, so it's very easy for us to link them in the similar way that we use for our internal dependencies. So we leverage this piece of Xcode setup project. The biggest workspace in our architecture is the main one. So the workspace building the entire solution, the entire application. We list all the projects that are on the map of our modular architecture. And this has few benefits. I will mention only 4 of them. So by leveraging the workspaces approach, we are able to compile the project, the entire workspace, very quickly, even if we follow the clean build. So after clean build, what happens is that Xcode attributes only the dependencies that are inside the workspace. And because in that workspace, for user engagement, we don't have this huge and fat monolith, long compiling monolith, we can build it within like 20 seconds, something like that. Dependencies inside workspaces are very explicit. So in that workspace, we cannot depend on something that is not inside. So for instance, we cannot link navigation project by mistake. So we cannot allow developer to link something mistakenly and introduce some clashing dependencies or something like that. Another thing is that divs, like workspaces, are very similar files. So workspace is like literally an XML file that lists only the projects that they're put inside, which means that if developer adds a new dependency to our workspace, we can clearly see it in a Git diff because it's very simple change. And workspaces give you test coverage reports for free. So when we run test bundle for that workspace, it lists all the targets that are inside and it lists the coverage report next to them. So if we have that many workspaces, if we have that many projects, how do we organize things in Git? How do we store the code? The answer is monorepository. So everything, like all the workspaces, all the projects are put inside a single repository. This gives us few benefits. For instance, there is no versioning problem. Just imagine that we would try to store everything in separate repositories. Then we will quickly enter the versioning hell. We would need to consider semantic versioning. We would need to consider backward compatibility. We would need to move around the repositories just to make sure that everything is on the same version. With monorepository, the version of our solution is the single commit in Git. Thanks to monorepository, we are able to quickly iterate on changes beyond the modules that we work on. So if I am a developer working on a user engagement project, for instance, and I need some small little change to another project, which is, for instance, VP Common, I don't need to go further than my local workspace. So I can simply apply the patch, apply the change to VP Commons, which is inside the same repository, and everything will be visible within the same merge request in code review process. Speaking about code review, we use the monorepository approach, lets us to use only single GitLab project, which is cool, because this, in turn, gives us very simple GitLab stream of GitLab workflow because we have only one single stream of merge requests. So the entire team works on the same project, so we can quickly follow what's happening and see what are the code reviews to be done.
Yes. Now to sum it up, that. Okay, so at the beginning we had like this huge monolith that we decided to split in multiple frameworks, in product, modules, and libraries. And those allows us to start new features effectively and quickly, to add a new architecture and new design pattern like MVVM, repository, and a lot of unit tests now. So what is the new shape of our code base today? So now it's a lot easier to understand because like each module and each library does what it says. So like the developer is not lost inside a huge code base. It's faster to compile thanks to the X workspace and Xcode. And that quick compilation brought us two things. The first one is like we are now encouraged to write more unit tests and even UI tests, and thus we have in return higher code coverage. Now we have like a true invitation for reusability, either through the VP commands or through all the other libraries. And at last, it's really simple to refactor, and now voice coding is even encouraged, and nobody fears it. But the things like the modularization brought us in like the huge successes was now we are able to develop features like really quickly and make them alive in the app really quickly, like much more than before. And of course, now the team is much happier to work in that code base.
So today, if we look at what we did with the modularization project, if we look at that journey from the past, like from the past into past, we came up with this conclusion that the initial cost of going with modules was not zero, because we needed to consider how to decouple our solution into modules. We needed to consider the initial effort of educating people on how to work with modules. We needed to learn a lot of things. We needed to consider how to store dependencies and literally all the things that we have showed to you today. At the same time, sticking to monolith would cost us zero. So there is no zero cost of initial cost by sticking to the module. But on a long run, so today, what we can observe is that the feature development effort is much lower than it used to be, or than it could be today if we would stay on the monolith path. So we are here right now, and we are happy that we are not there. But this is our story. This is our approach, and this is what worked for us. And we personally think that this point, the point where these two lines crosses, is something that every team should consider before he enters that journey, because there is a cost, but there could be also a benefit from that. Thank you. This was everything for tonight. We are happy to be there. If you have any questions, we are open. We have some bugs to distribute.
Hi, great talk. Thanks. You mentioned a few advantages of monorepo. Did you experience some disadvantages of monorepo, for example, Git performance or long build time of the whole application, or long startup time, because dynamic frameworks increases up startup time?
So speaking about the monorepo, and startup time is something like, for me, it's something separate, because startup time is like can be affected by linking too many frameworks into one application. Yes, this could be the issue, but with the number of frameworks that we have already, it's not the case for us. The app can still start quickly. We have some monitoring, we have some automation behind that, so we use Grafana to apply some monitoring. So every night we run the app on a device to put the dot on the Grafana and to see what is the trend behind the startup time of the application. So we are aware of that this could be affected, but it's not the problem for us today. Speaking about mono repository and some disadvantages, I think the only one that came to my mind is exactly what you said, the size of the monorepository, the size of the repo. Right now it's 5 gigs, I think. So there is the initial cost of onboarding the new guy to the team and like telling him why he's so surprised about the size of the repository. But beside that, I don't think so. Like nothing special that like stopped us from doing things.
Yeah, thanks for the talk, first of all. And I wanted to ask, because on the start of the presentation, you have mentioned that you had a problem with clean build on your CI with the time. And how does it relate to a monorepository? I mean, technically, it shouldn't affect the clean build time. Or how have you solved this issue?
So it does not apply to monorepository, right? Because like we use GitLab. GitLab has some optimization for not checking out the entire solution. It uses the detached head on Git, so it's like quite fast when it comes to like getting the repository on the machine and running things. The first thing that we did is to apply some of the compiler optimization. Second thing that we did is we leveraged the workspaces, so the distribution of all these frameworks, which maybe does not impact the compile time on CI like significantly, but it's more about reducing the clean build on developer's machine where we don't build the entire solution. This is first thing, and it also impacts the incremental build time. So we are able to build things quicker. So if speaking about the CI and like the clean build time on CI machine, no, it does not improve this thing. We improve it in other ways by tweaking by playing with compiler flags or by buying the quicker Mac Mini, which is like the best solution ever.
Okay, hi. Yeah. You have many workspaces with many test suites. So on the CI, do you know which test suite should be run, or do you run everything, no matter what the changes were?
Good question. So on CI, we run only the tests for the main target, for this entire solution. We don't care about running tests, separate tests, of doing separate test runs on other workspaces, which is something that we could improve, because sometimes what we spot is that developers are not so. Sometimes developers break the builds within their workspaces. So the one idea that we have in mind is to at least try whether the separate workspaces do build. We don't need to run the unit tests, because the unit tests for separate workspaces for all these projects are included in the main workspace. But we want to check whether the workspaces at least build.
Okay, thank you.
I have less technical question, but more from a perspective of a product owner and the business. Did you encounter any problems with telling business people and product owners to follow the new way, to invest time and money to refactor your application?
So that is something that we explain in the company, that sometimes we need to do some refactoring, so the features will be like, we will wait and they won't be like the outer priorities, and they were comprehensive, so we have been doing our refactoring when needed, and it was okay.
And I think the trick is to start small, so to not like put entire team on their huge refactoring session, just start small, create your first module, start some work on that, show that there is a benefit behind that, and then I think this is the way to speak with the business. Like the true benefit of some money, some time, which is money, right?
Okay, so like, because I don't know if I understand that correctly, you have like a core that is composed with VP, right? Stuff, and you have products that are separate models, right? So my question would be like, do you often have a trouble when the line between modules, so basically dependencies should go horizontally between product modules, and how do you solve them?
So we try to not to have that kind of dependencies, and if that could happen, and if like it's more UE related or like date formatter or that stuff, we try to put it in the VP commands.
All the code that's connecting the models is basically in the main application, right? In the monolith.
Yes, in the old monolith. The old monolith is the one that hosts all the products.
Yes, so like if because I understand that you have one team working on one module, right? So when basically one team works on one module and brings some feature that needs to connect two modules together, so how is that solved?
Yeah, so there is a lot of bridging. So for instance, if if we look at the user flow, so user enters the user engagement module, and then he's being set, or maybe better, user enters the navigation module, which is the list of sales for us, and he enters the marketplace, so particular sale. The thing that happens is that from market navigation module, we send, to keep it short, we call a delegate, which is stored inside the monolith. In that monolith, we transfer the information, the domain model from navigation project to domain model for marketplace. So there is a lot of like jumping up and jumping down and transferring the domain between two modules. So the old monolith is responsible for this transfer logic.
Yeah, so it works like a bridge between the modules, right?
Exactly.
Yeah, so do you have a lot of like clashes between pull requests where someone deletes something or adds something?
No.
No?
No.
Oh, cool.
Like actually, the developer from the team in the feature teams owns the part of the monolith where they're like in charge of calling their module. So usually don't go to the part of the user developer sometimes.
Okay, thanks.
And we are still 10 developers, so we know each other, we know what we are working on, so there is like this human factor to discuss something and to not run into clash. Okay.
Any more questions? No.
Thank you once again.